Does this thing really exist? Some say that... Wait. No, the title and thumbnail are not a clickbait. What I'm saying is that, purple doesn't actually exist. Your first thought might be, what? I'm literally looking at a purple object right now. What are you talking about? Well, let's get funky. As it turns out, this thought can be absolutely right. The truth is, the way we experience the world around us is largely a giant illusion fabricated entirely inside our own heads. Color is not an objective physical thing just floating out here in the universe waiting to be seen. It is a translation, a biological trick. By the end of this video, you are going to understand exactly why some of the colors you see every single day, specifically colors like purple, are technically nothing more than a glitch in your biology. Let's get into it. Colors and their perception are quite a thin ice. Think for a moment about what a red is. You might have thought about it yourself before, such as how to explain a red color to a blind person.
Over the years, just people have tried to explain color to me, and I just don't understand it. I think the best way to show you is to try and explain to someone who's never heard before what the ocean sounds like, or what the birds sound like. And that's where color is for me. Because somebody who's never heard doesn't know what those things are, has no concept, none. So when somebody says something's red to me, I don't quite get it. I know that red is fire, or a stoplight is red, but I don't know what it looks like.
Well, the answer is easy. You cannot. This itself has quite a potential to break our conviction of what is real. Let's make it weirder. There is no way I can prove that what I call red is not your perception of blue. I have no way to know if my parents during my childhood saw the same colors as me, meaning perceived them in the same way and told me their names associated with the same perception as theirs. So, what if everything I'm seeing as red you see as blue? It might be the case. We will never know. Probably. To understand why purple is a lie, we first have to talk about what light actually is. Most of the universe is swimming in electromagnetic radiation, just waves of energy traveling through space. Radio waves, microwaves, X-rays, they are all part of the same spectrum. But there is only one tiny, narrow little strip of that spectrum that our human eyes can actually detect. We call it visible light. Think of a standard rainbow: red, orange, yellow, green, blue, indigo, violet. As you move from red to violet, the physical length of the light waves gets shorter. Red light has long stretched-out waves, while violet has tight, scrunched-up short waves. And here is the absolute golden rule you need to remember. Every single color in that rainbow is a spectral color. That means it is a real, physical thing processed and understood by our human eyes. It corresponds to one exact specific wavelength of light floating around out there. But if you look really closely at a real rainbow, you might notice there are very common colors completely missing from the lineup. By the way, I'm using human eyes here on purpose. If you happen not to be in a human form, then welcome, I guess. Or if you are interested if your pet sees the same things as you, well, probably not. The red color, for instance, or already any rainbow spectral color, has a well-defined value, but its perception depends heavily on the receiving system. So why is the purple color missing here? But I can still see purple. To answer that, we have to look inside our own eyeballs. At the very back of your eye, you have millions of tiny little light-detecting cells called cones. For humans, we have three specific types of these cones: long wavelength sensitive, medium wavelength sensitive, and short wavelength sensitive. Think of them as three different microscopic sensors. One type is mostly sensitive to red light, one is sensitive to green light, and the third is sensitive to blue light. RGB. Sounds familiar, right? It is exactly how the pixels work on the phone or computer screen you are watching me on right now. When a light wave enters your eye, these cones wake up and fire off electric signals to your brain. And here is where the translation process happens. Let's say a beam of pure yellow light. a single real wavelength hits your eye, you don't actually have a yellow cone, but that yellow wavelength physically sits right between red and green on the light spectrum. So it triggers your red cones a little bit, and it triggers your green cones a little bit. Your brain receives both of those signals at the exact same time, does some rapid fire subconscious math, and concludes, okay, red and green are both firing, so we must be looking at yellow. It is a beautifully elegant system for decoding the physical universe. You might be pretty confused right now. We talk about yellow, which actually is in the rainbow, and at the same time I said it triggers red and green cones. Good point, dear viewer. It might happen that two different stimuli, like one color or a combination of two colors instead, might lead to the same result for our perception system. This is called metamerism. But what happens when the universe throws your brain a curveball it literally cannot handle? Imagine looking at an object that is reflecting pure red light and pure blue light at you at the exact same time, but absolutely zero green light. Your red cones fire, your blue cones fire, but your green cones stay completely silent. Now, your brain has a serious problem. It looks at the linear spectrum of light and says, okay, what is exactly halfway between red and blue? The answer is green. But the green cones are screaming, there is no green here! And the brain panics. It is receiving conflicting data that cannot exist on the straight line of the physical light spectrum. It simply can't process a color that is simultaneously at opposite ends of the spectrum without the middle part. So what does it do? It improvises. It takes that straight line of physical wavelengths, bends it around into a circle to bridge the empty gap between red and blue, and completely invents a brand new color to make sense of it all. It creates purple. The correct scientific term for colors like that is non-spectral colors. A spectral color is one that has its own specific physical wavelength, like we talk about with the rainbow. A non-spectral color is one that requires a mixture of different wavelengths hitting your eye at the same time for your brain to perceive it. It doesn't have its own dedicated spot on the physical light spectrum. And if learning that purple is a biological fabrication just blew your mind, wait until you hear about the other imposters. Purple is definitely not the only fake color out there. Think about pink. You will never find a pink wavelength of light. Pink is literally just red light mixed with white light, and your brain just sort of softens it up. Or what about brown? Brown doesn't exist on the spectrum either. Brown is actually just dark orange, but your brain only allows you to see it as brown when it's placed next to brighter colors. It is entirely dependent on context. Even white isn't a single color. White is just the output your brain gives you when it gets bombarded by every single visible wavelength hitting your eyes all at once. It's basically the visual equivalent of static. So, does the purple color exist? Yes, of course, I can see it. No, it does not. It doesn't have any real background. Well, you decide. It is actually quite a fun conversation to have, and now you understand it well enough to choose your stand. Or change it whenever you want just for fun to annoy people around. The truth is that the brain invents the purple color, but to be fair, our brains invent all colors. Color is just our neurological translation of electromagnetic radiation, and we are still talking just about humans. When you increase the number of types of color receptors, such as 12 for the Mantis shrimp, now we are talking about something absolutely not imaginable for us. Like a blind person, you cannot imagine a color you have never seen before, especially a color that your system cannot even process. And we can get even weirder. Can you imagine a reddish green? Not yellow, but there is something red but green at the same time. I bet you cannot, but write me a comment if yes. As a cherry on top, let me mention a difference between purple, violet, and magenta, because people mix these up all the time. Violet is completely real. It is a true spectral color sitting right at the very edge of the rainbow, just past blue, with its own short physical wavelength. Magenta, as we just talked about, is completely made up. It is non-spectral bridge your brain builds when it sees pure red and pure blue at the same time. And then there is purple. In everyday conversation, we use the words purple and violet to mean the exact same thing, but scientifically, they aren't. Purple is actually a non-spectral mixture of red and blue light, very much like magenta, but usually just leaning a bit more towards the blue side. So, to put it simply, violet is actual physics, while purple and magenta are just your brain doing its best to fill in the blanks. So, at the end of the day, as a physical standalone wavelength of light, purple, magenta absolutely doesn't exist. But as a psychological experience, as a clever workaround for our brains to make sense of a chaotic universe of a bouncing energy, it is very, very real to us. Which really makes you wonder if our own biology is just casually inventing colors to fill in the gaps. What else about our everyday reality is completely made up? What other things do you think our brains are just faking behind the scenes? If you like to think about light, its perception and possible impact on health, check out this video where I analyze blue light. And that would be all for today. If you like what you saw, hit the subscribe button. And ciao!